Hello friends, welcome to my channel Code Destination. So today we are considering the topic binary search algorithm. So we are continuing our challenge one code one day. So today we will discuss about binary search algorithm and how we can understand the binary search and how it help to search any element in efficient manner. And after that in upcoming days we will discuss the various type of various variant of binary search, we can use how we can use binary search in different type of questions. But for today we will understood the algorithm only. So let me share my screen. Yeah, so first of all, what is searching algorithm? So basically searching is a methodology. Like suppose you have given any array. uh, in this, suppose I'm taking an example 1 2 8 9 0 and 3, and suppose I want to search any element, uh, suppose 8. So what basic approach generally we follow for searching any element in the array? We generally iterate in the array and we compare each element. Like first we compare 1 to 8, then if I will compare 2 to 8, then 8 to 8, and if any element match with the target element, then at that time basically whatever question want, like suppose question want index, so I will return 2, and the question want true or false, then I will return true or false. But in general it will take the, like totally, like we have to iterate in the whole array, so totally it will take an iteration. So in the, if I am talking about time complexity, so time complexity will be the big of n. So is there any way to search in the optimum manner? So basically I can say no, because if random element is given in the array, so it is sure that we have to check each and every number for getting that whether the target number is element is present in our array or not. But yeah, suppose this array is given sorted manner, so what benefit we can get? Suppose it is given like that 1 2 3 0 1 2 3 and 8 9. So if it is given in the sorted manner and like in question, and it is saying that find the target value 8, so it is a first example where the random value is given. So in that case, yeah, it is sure that we have to check each and every number for searching any target value, whether the target value is present or not, because there are no pattern or anything in the array, so we can't do anything. But if suppose in the second example the sorted version, like sorted array is given, so in that case we can get, like we can observe something. So suppose any sorted array given, so what observation we can get? Basically the first observation we can get that the first element will be always the lesser element, like at the 0 index always the lesser element will present, and at the last index always the greater element will be present. This is the first observation. What is the second observation? The second observation is that whatever element you select from the array, like suppose I select this element, all the element before that, like all the element before that will be less than particular element, because here suppose I select any ith element, so all the element present before that, it means ai will be always less than aj, and where j will be less than I. Okay, so for all element which is present before the particular element, that will be less than that element, and all the element, suppose I write that ak, any element will be greater than ai for all k greater than I. So these two condition fulfilled when we pick any sorted array. So these two observation we can get from this array. So basically that first observation is also the part of this one, because the first element is the less, because before that there are no element present, so that will be the lesser element, and the last element will be the highest, like largest element, because the right side of that element is like no element present at the right side. So in this way, these two observation, how we can utilize these two observation for searching any element. So how we can do that? Suppose I am taking this example same 0 1 2 3 8 9, and I want to find any target element, suppose 8. So if the like element is giving like given any order, like there are no sorted element given, so in that case we are just starting searching from here, 0 index, we search this element, then we compare this element, we compare this element. But it is sorted and we know this behavior already. So instead of searching from start index, so we can think, can we search in between somewhere? So yeah, so if you think in between, so always we think like, can we search in the half part? So suppose this size is given 1 2 3 4 5 6. Suppose this element is size is 3, sorry 6. So what is the half of this? 6 by 2, 3. So first we compare third element. Suppose I write this indexes. So I will first pick this element. So I will search here from here directly because it is given sorted. So if we start searching from middle, so what benefit we can get? Like first we'll search this 3. So this 3 we can compare with target. This 3 is less than 8. So if any element is less than 8 in the sorted array, so like according to our observation, like if this 3 element is less than, like this 3 element is less than 8, so it is sure that all the element before that will be the also less than 8, correct? So it means we can neglect this part, correct? Because this if this 3 element is less than 8, so it is sure according to our observation, this observation, that all the element before that, all the jth element before ai element, suppose ai is 3, so all the third index element, if my I is 3 and j is like less than 3, so j is 3 means 0 1 2. So for 0 1 2 all the element will be less than this 3 a of 3. So we can just directly ignore all these element, and now where we will search, we will search only the right part. So we can see here what benefit we can get. Basically whenever we search from the half part, so one half part in every case we can ignore, correct? So in this way it will take less time, because previously we was searching in the whole array. Suppose this is the n size array, so it was searching in a whole array and it was taking the total time, like total iteration n and total time complexity big O of n. But in this case we are just ignoring every time half part, like we are searching this a3, so 3 is less than 8, so just we ignore that, and in that case we will search only the right part. So we will search here on the right part only. So again we will find the half of this, like same methodology, like what is the half of this? Half of this is 8. So again we will compare this 8 is equal to 8. So in that case we get, so we get basically in the first iteration we search this one, in the first iteration, and the second iteration we just search this one. So we can see we can search only 8, like we can find our target element only in the 2 iteration if I calculate that. And here if I follow the if I follow the linear approach, like I search each element and compare, then in that case it will take how many iteration? 1 0 1 2 3 4 5. So it will take 5 iteration. So in the binary search it is taking, like if you are searching in the binary manner, so it was taking 2 iteration, and if you are searching in the linear manner it is taking 5 iteration. So we can here we can also observe like this 2 iteration is just the half of the 5 iteration. So basically approximately half of the time we are saving here. So I hope you understood why, like if the sorted array is given and what benefit we can get according to our observation, and how we can search in the like array, and why we are searching from the middle. Because if any case if we talk about searching anything in between instead of starting, so we generally prefer the middle part. So generally we start searching from the middle and we just ignore half of the parts. So let me define the time complexity for this binary search. So let me take a same example 0 1 2 3 8 9. So for 0 1 2 3 8 9. I am taking this example and I am searching the eighth element. Here I am searching this element. Okay, so what we are doing, suppose in a general case I am assuming this is the n size element. So every case, what we are doing, we are just first searching in the n by 2, like here we are searching, first. Okay, so after that we are just searching half of, and every iteration we are ignoring the half of the part. So suppose in the first iteration I am searching in the n array, then in the second iteration I will search in the n by 2 array, because in the first, like if I compare this 2 with the 8, I can like ignore this first part. So basically now my the search search area is this one, n by 2 part. So in every case we are just like ignoring half of the part. So in the first iteration I am searching in the n array, in the second n by 2, and in the third again I will like take n by 2 by 2, because here I will search. So again this is n by 2 and I will take the half of the part of this. So n by 2, so 2 into 2, it means 2 square. Then again I will take n by 2 in 2 square by 2, 2 ke power 2 power 3. So suppose in this way, in the k iteration, like in the kth iteration, I found my element, and suppose that total number of iteration is t, I assume. So what will be that? In that case I can find the pattern here. Suppose in the first iteration I am searching 2 to the power 0, to the power 1, 2 to the power 0 equal to 1. So n by 1, either I can say n by 1 or n only. And here 2 to the power 1, 2 to the power 2, to the power 3. So in the for the kth case, suppose in the kth iteration I found the element, so 2 to the power k, and this is total time complexity. So like basically I have to find this k in the k time I am finding the element. So if I find anyhow this k, what the value of k, so that k will be our time, like total iteration, number of iteration. So this is the n size of the element. So in the kth iteration I found my element, and that, suppose that is total iteration t, I assume. This is assumptions. So for finding the k, generally what we took, like for getting our power in the base, we generally took log. So I will take the log from both. So it will, I will take the log here to the power k, sorry, not it is here, and log t. Okay, so just I will shift here and minus log t, but I assume it is any constant, because it is a constant, like any constant term, because it is taking any constant time. So I can assume here, and here I can take log 2 to the power k. Okay, so if I want to find this k, so it will be k log 2. Okay, and this log divide by both. So in the, like if I shift here, so it log 2 base and log 2 t. So this is the k value. So in the term of n, if I want to represent, so because this t is somehow any constant values, I can ignore. So k will be log base 2 n. So this is the k number of, like k is the our basically total time taken. So k, the kth value is log n. So basically in the worst case it is taking a log n, sorry, in the, like in the binary search it is taking a log n time. So if I calculate the time complexity for this binary operation, so it is taking a log n time complexity. Basically this k is the number of operation log n. So if I convert in the time complexity, so big O of log n base, nothing matter because base is constant 2 or anything, but yeah, in the case we are dividing array like each time by 2, so that's why in the base we are coming, like we are taking this 2. So and why we, and that is the reason why we say this binary, because like it is coming 2, and everything what is, like we can define the two element, that is called binary. So basically that is called binary search algorithm here. So in this way we can calculate the total time complexity of binary search. So I hope you understood the logic. Let me start to implement in the code. So for today I took this problem from LeetCode, problem number 704. This is the binary search. So first quickly I will implement how we can search in the linear manner. So I will iterate in that case in the linear manner first. Okay, I will iterate like that, and I will just compare each element nums of I equal to target. In that case I have to return that index, and if it is not found, then in that case I have to return -1. And if I suppose I'll run this, so it will work. Yeah, it is linear solution. Let me submit it first. Yeah, so it is taking 1 millisecond and beats 10.34 of users, but it is all not a good solution. We can optimize more using binary search, because in the question it is given an array of integer which is just sorted in ascending order. So we can just get a benefit according to our observation, like we did our observation. So that for that observation we can say that if it is sorted, so we can use the binary search. And for that what I have to do, I have to just take a 2 pointer, like low, and second pointer is high. Okay, and I will make one while loop till low equal to high. So every time basically this define our whole area boundary. I just define the boundary low and high, and for like in the while loop it will run till my low is less than equal to high. And in every case I will find first middle, so low plus high minus low by 2. So I found my middle, and I compare if my middle value is equal to target. If it is equal, then in that case I have to return that index, middle index. And else if my target value is greater than nums of m, okay, my target value is greater than nums of middle value, it means my target is present at the right side of the array. So in that case what I have to do, I have to just shift my lower boundary. So lower boundary will be middle plus 1. And if another case, like if my target is less than nums of m, if target is less than nums of m, okay, it means I have to shift my right boundary. Let me explain you what it's going on here. So suppose this is 0 1 2 8 6 5 3. So we are founding the 8 here. So what we are doing here, I just define this lower and higher pointer just for defining the boundary. And every case I just found the, suppose 8 is present here, not here, because in that case it will just come here. So first I found my middle. So in the middle, suppose I get any middle index, and this 5. So if 5 is my middle value, is like my target is greater than 5, or my middle value is less than my target value, it means all the element before that will be less than target. So if my target value is less than, maybe I can write that one, less than nums of m here. If my target value, my 8 is less, sorry, in this case like 8 is if my target, sorry, middle value is less than target value, so I will shift my lower boundary. So this lower boundary will come here, because I can ignore this part. So my lower boundary will come here and higher boundary will come here, because I will search in that array now. So if my middle value is, I can write like that to be more clear. If my middle value is less than target, so my lower boundary will shift after the middle, and in opposite case my higher boundary will shift before the middle. Okay, because in that case I will ignore the right part, and if it is equal I will return that index. So here, and if I didn't found, so in that case -1 will be written. So let me run it. So it accepted. Let me submit it. So we can see it ran and it is taking 0 millisecond. Previous solution was taking 1 millisecond, but it is taking 0 millisecond and 100% user of bits. So let me quickly try run this, how it is running with this example, then it will be more clear. So for this case, like if we are ignoring the left part, so I think you understood, we are just shifting the left boundary to the right. But suppose I'm taking an example where this sorry, I took the wrong example here, because it should be sorted. So 0 1 2 5 6 8, this three should not be present. So suppose I took an example 0 1 2 8 6 sorry 0 1 2, this is a 5 6 8 and 9, it is sorted. And we want to find the element 2. In that case my target value is 2. So what it will do, it will first define my lower boundary, then higher boundary. So it will find the middle 0 1 2 3 4 5 6 7. So 7 by 2 3. So 0 1 2 3, it will search this one. So my middle will come first here. So my middle value is greater than target value, so it means all the element after that will be greater. So basically we have to ignore this one and we have to search in that part. So in that case I have to switch my higher boundary to the before the middle, so my higher boundary will come here. So in that case I can show you in the code. In that case, in the else condition, my higher boundary will be minus minus I am minus 1. So I will search in the like next half part. So in this way it is running. So I hope you understood the logic of binary search and how we can implement in the code. So if you like the explanation and you understood, so please like this video and subscribe my channel, so that in future if I upload any video you can get and you can understood the topic. So maybe in future I will share the more variant, different type of variant of binary search, how we can utilize the binary search in different type of questions. So yeah, thank you for watching my video.